Good day, my name is Brand Wessels. The research that I present today will be about the mitigation benefits of locally produced wood materials for South African residential construction. Most of this research was done by a PhD student of mine, Philip Crawford. South Africa do not really have a wood building culture. Less than 1% of our residential houses are built from wood. In our research, what we wanted to see was what the potential environmental benefits will be if wood become the dominant material for building residential houses. We also wanted to see if our local forest resources can sustain a large wood building sector. This graph by Allwood et al. Separated global carbon emissions into 4 categories. And as you can see, buildings are linked to roughly 1/3 of all carbon emissions. How we construct and live in buildings is therefore a pretty important question. To summarize our research questions then, those were: how do wood compare to competitive building materials in terms of environmental sustainability, of course in the South African context, and what will the global warming potential impact be if wood become the dominant residential building material in the country. And we also wanted to know whether we can sustain a dominant residential wood building sector with local forest resources. And although it wasn't part of the original research for this paper, we also look at the potential policy implications. In South Africa, the only place in building where wood is used extensively is for constructing roof trusses. So we started off our research by comparing different materials in terms of a life cycle assessment of roof truss manufacturing. We look at 2 different house sizes common in South Africa. So one would be a social house of about 42 square meters, and the other one a medium-sized family house of 168 square meter. We compared the 3 materials available for roof trusses in South Africa, which will be South African pine, eucalyptus timber, and light gauge steel. Manufacturing from pine and eucalyptus is quite different, so that's why we dealt with them separately. We evaluated the environmental impact of roof truss construction over 11 different categories. Those include acidification potential, climate change, depletion of abiotic resources, and quite a few other categories as well. And this graph just shows the normalized impact for the 42 square meter social house. The final category on this graph is, as you can see, is the average impact over the 11 categories, and you can see that the steel roof trusses had about a 40% higher impact on average over those 11 categories. If we look at global warming potential on its own, you can see in this graph that the differences are much more pronounced. You can see the red line will be the light gauge steel, and the global warming potential effect is about 500% higher than the 2 timber options. Next, we wanted to see what the effect will be if wood-based building replace the traditional masonry building effect. In this graph, you can see the building activity in South Africa from 2000 to 2016. The different color bars include houses smaller than 80 square meter, houses bigger than 80 square meter, as well as flats and townhouses. In this area, on average, there were about 54,111 houses built per year. The average house size was 114 square meters. Currently in South Africa, our population growth is about 1.3%, but that is declining, and we expect population to start declining in less than 40 years. So in our modeling, we just stick with the average house numbers built over this area, which is 54,111. To get an idea of what is realistically possible in terms of wood-based market share for residential houses, we looked at trends in different countries. This graph shows trends between 1992 and 2017. In South Africa, you can see we basically stuck at below 1% wood-based market share. In Germany, there was a wood-based market share of about 6% in 1992, and that increased to 18% in 2017. England was also at 6% in 1992 and was 27% in 2017, and I believe it's now more than 30%. And then in USA, the wood-built market share was always well above 90% of all residential houses. In our study, we used international literature to predict global warming potential of building systems, since we didn't have any local data. In some cases, the global warming potential was adapted to incorporate South African primary energy production values. And we also made assumptions of the relative market share of types of building methods, such as timber frame or cross-laminated timber, based on current trends. This graph shows the reduction in global warming potential for 3 different wood-based market share scenarios. The first one is where there is a 10% new build wood-based market share, the second one 20%, and the third one is where all new constructions, residential constructions, will be wood-based. The dark blue bars are, based on literature, the minimum expected reduction in global warming potential, and the black ones the maximum. So you can see, for instance, if we have a 20% wood-based building market share, then the reduction in global warming potential for the residential housing construction sector would be between 4.4 and 13.7%, which I would think is a not unrealistic target if you look at the trends in Western Europe. If in the longer term we become like Canada or USA, a dominant wood-based market share, then the global warming potential will reduce by between 23.1% and 71.5%. The next question was what size wood-based residential market we can sustain in South Africa with local forest resources. Here in this table we list 3 possible options. The most obvious one is current wood chip exports to Asia. We export quite a lot of eucalyptus and wattle chips to Asia. It will be hugely beneficial if we can use this resource for rather for building components, because at the moment there's very little value addition in the exports. If we use that full resource for housing, it is possible to build about 47,500 houses. Remember, our average house size at the moment is about 114 square meters, and we build about 54,000 houses annually in South Africa. It's unlikely that this full resource can be used for housing. There are some technical challenges using some of the species for building, and that's an area where we currently do a lot of research in. The second possible resource is forestation in the Eastern Cape and KwaZulu-Natal. That's areas that government has earmarked for afforestation. That resource will enable about 37,000 houses, but it will, even if we start today, it will only be available in about 24 years' time. And then finally, there's also some potential for dryland afforestation in the Western Cape of 175,000 hectares, but that's mostly on privately owned farmland. this just shows that we can actually sustain a dominant market share of wood-based buildings, but we will have to plant some new forests for that. For increased forestation, current trends will have to be reversed in South Africa. This graph just shows the plantation forest area in South Africa from 1980 to 2017. And you can see that since 1997 we've actually had a decline in forest area, this coincided with the introduction of government policies which made it very difficult for private landowners to establish plantations on their properties. The legislation was mainly aimed at limiting water use of plantation, and it included onerous administrative processes, and they also added a water tax for forests on the runoff that it used. And currently no other agricultural crop has the same type of requirements on them. If you consider that forestry and forest products in South Africa use about 5% of all agricultural water, while that sector produces about 10% of the agricultural GDP, forestry is actually a very efficient water user, and government maybe need to reconsider some of their policies here. Finally, what are some of the policy implications of our research? As mentioned before, the policy environment for plantation establishment in South Africa should be reviewed, because it's currently very difficult for private growers to establish new plantations. Secondly, government's own purchasing and building policies could promote wood-based products, and the Department of Trade, Industry and Competition is actually looking at that at the moment. So there is the possibility that they will bring in legislation around that in the future. And finally, the wood-based building sector is it's one where technology and products are currently evolving pretty rapidly. In South Africa, we have a fairly unique forest resource that's very different to that in the Northern Hemisphere. And research to support development and production of building products from our forest resource will be very important for a growing wood-based building sector. And therefore, we should have a national forest products research strategy. And actually that's also something that the Department of Trade, Industry and Competition is looking at, and we will hopefully in future have one. Lastly, just acknowledgement for the Hans Merensky Foundation for funding this work. Thanks for listening.